Our first guest is Dr. Jacques Chenet. He's senior geneticist with the CEMEX Alliance, a world-leading Canadian dairy cattle breeding company with exports of genetics in more than 80 countries. Today, Dr. Chenet will present the Dairy Research Cluster projects in genetics and genomics, as I mentioned, and those are all supported as well by our partner in the Canadian Dairy Network. So welcome, Dr. Chenet, and he will be presenting in French.
Merci, Shelley. I'm going to make the presentation in French, as Shelley just said. Je vais commencer aujourd'hui.
Today I'll speak to you about the advances in genetics and genomics over the last 5 years and the 4 genetics and genomics projects we have underway in this field. Now, when we analyze the data of milk recording over a rather long period, we note that genetic progress can account for the enhancement of productivity amongst dairy cattle, more than 70%. And this is what we find for Canada and for other countries. Over the last years, there have been major improvements in terms of genetics and genomics, and this is what I'll be tackling to begin with. If you see this graph, well, what this graph shows is the increase in the annual genetic progress for cows born according to the year of birth of cows born between 1990 and 2015. What we see here is pro dollar, the increase in genetic product in terms of pro dollar. It's an economic index calculated by CDN based on the Valacta data that measures the net profits of each cow up to age 6, up to the year of 6 years. Now, it takes into account the price of milk, components, the cost of feeding, the cost of breeding the heifers, and it reflects not only the production of cows, but their sustainability. If for reasons of production or health the cow doesn't produce anymore, well then it does no longer contribute to the revenue. And on this graph we can note that as of 2009, the rate of annual genetic progress in terms of pro dollar has doubled. It has gone from $80 a year to $171 a year, which is a tremendous increase. It had never been observed since the advent of artificial insemination some 50 years ago. And this is due to the fact we now use genomic evaluations that allow us to select earlier the young animals and to have a rotation of generation that is quicker. And with genomic selection, we can select more efficiently for health, fertility traits, and longevity traits, for which it was difficult to make a selection in the past. So on this table, we've converted the genetic progress I've just shown you in net annual economic value to the industry by using assumptions that are rather conservative. I will not get into the details because we don't have time, but it does show that the net annual economic value to the industry was $265 million a year before the genomics, prior to 2000 and now. It's now $540 million a year for the last 5 years. We can even make predictions for the future on the basis of the genetic value of the new cows, the cows that will be produced over the next 5 years, and we see an increase that goes up to $748 million a year. These are big numbers that show that over the last 5 years, the genomic revolution has really had an impact and is bound to have an impact on the productivity of the overall sector. This table shows you the funding of research in genetics and genomics by the industry. In this case, by the members of the Canadian Dairy Network, which are the breed associations, the AI organizations, the milk recording, and Dairy Farmers of Canada. And you can note that as of the year 2000, we've invested close to $7 million in research in genetics and genomics. We've managed to obtain $14 million from the government as matching funds for a total of $21 million, which is not bad and is undoubtedly a very good investment if you compare it to the benefits we draw thanks to genetics and genomics. I will talk to you about the 4 genetics and genomics projects that are supported and funded by the cluster. They're all underway. They should end in March 2017. And the first one has to do with the development and testing of new methods for genomic evaluation in dairy cattle. The second is what we call the 10,000 dairy cows, the 10,000 cows genome project. Third project, improving hoof health in Canadian dairy farms. And the fourth one, improving cow health and the nutraceutical value of milk with infrared technology. The first project aims at improving the accuracy and speed of current genomic evaluation methods. This allows us to increase the rate of genetic progress. And even if we've made huge progress thanks to genomic evaluations over recent times, their accuracy is 50 to 70% for the main traits, and we could, by improving the methods, go from 60 to 80%, and this will have a major impact on genetic progress. So what have we managed to do so far? First of all, we've developed a method that allows us to estimate the reliability very quickly. This method is already used by CDN to calculate the reliabilities for genetic evaluation for animals on a weekly basis, so it goes very quickly. We've also developed a new genomic evaluation method based on what we call haplotypes, blocks of DNA rather than markers, and that we hope will be more specific than the method we currently use. This method has not yet been validated, and this is what remains to be done. And if the results are positive, we will transmit it to CDN. The second project aims at increasing the accuracy of evaluations by using cow genomic information, and we want to pave the way for gene discovery using sequence data. Sequencing is a technique that allows you to obtain the order and nature of the 3 billion genes in the cow. Currently, genomic evaluations are only based on sire proofs. Cows are not used. We could do better with cows, but we're afraid, since that there might be preferential treatments, we have to find a new method to include cow data and enhance their accuracy. In order to do so, we have launched a project genotyping 10,000 cows across Canada, generally speaking cows with good phenotypical data, and try to introduce them in the evaluation, introduce their genotype in the evaluation, and at the same time, we try to predict the sequence of the genome of those cows so that we can discover new genes. So far, we have been able to genotype 5,000 of those cows out of the 10,000, so half of them are done. And we have imputed to sequence 3,000 of those cows with an accuracy to the tune of 97%. So very good results that should allow us to undertake a more in-depth study on the impact of genes on the various production traits, health, fertility, herd life, etc. The next steps will allow us to test new procedures for the use of cow data, as well as start the system to discover genes. I won't use the word pipeline, initiate the pipeline for gene discovery. It's pipeline is not a very popular word these days, and look at the interactions between genes for traits such as health, fertility, and herd life. The third project is a project on hoof health. It aims at centralizing data collected by hoof trimmers into a coherent and sustainable national database, and then develop herd management tools and genomic evaluation to improve hoof health. It's a serious issue for the industry. According to the scientific studies that have been conducted, 40 to 70% of cows in North America have at least one hoof lesion in their career. And the economic losses associated with these problems are huge for the industry, but there is also an aspect of animal welfare that we should be able to resolve as well as possible. You see the results that we have obtained, the various lesions that we assess. The first column represents the frequency of those lesions as we observe them, and the second column is the heritability of these lesions. And the major lesions is the digital dermatitis and sole ulcer. And when you look at the heritability of those traits, they're rather low. But still, there is a major genetic variation. If you look at the graph on the right-hand side that has the genetic evaluation of bulls, and on the other axis, the percentage of daughters that have no lesion to their hoof, we realize there could be major differences depending on the bull. The 10 first bulls had 6% of lesions for their daughters, whereas the bottom 10% had over 24 daughters with digital dermatitis. Now, what have we done so far? We've been able to calculate genetic evaluation, preliminary genetic evaluation for health hoof. They haven't yet been disseminated. These are research findings. Then we've also completed an interface to transfer data from the hoof trimmer tablets to DHI and to CDN in order to create a national database, and in order to send back the information to hoof trimmers so that they can offer better management to producers. And by the end of the project, we hope we will have genomic evaluation for hoof health for all sires and cows, and we would like to have between 10 and 20% of cows in Canada in our national database, and we hope it'll go up afterwards gradually. The fourth project ties in with the presentations you've heard so far and has to do with the improvement of the nutritional or nutraceutical value of milk. The goal is to develop selection tools for improving the nutraceutical value of milk. And these are tools we want to develop, and the directions we'll take will depend on what the industry wants us to do with the help of nutritionists and dietitians. We have to know that in Canada, milk recording use infrared to measure levels of protein and fat in milk, and it allows us to measure more components like the percentage. It allows us to predict many more components like the percentage of fatty acids, lactoferrin, calcium, etc. So potentially we could access a huge database to do selection or management for those traits and therefore improve them. So improve, on the one hand, the nutritional value of milk and also the health of cows. What we've done so far is that we've already transferred 2.4 million infrared data from 600,000 cows to a database in CDN. We've analyzed 2,500 milk samples from 400 cows for the size of fatty acids, etc. So, and casein micelle size, so we could compare these lab analysis with the infrared data, and then we'll conduct analysis for other traits such as calcium, casein, phospholipid content, and lactoferrin. So far, what we've found is that the traits we've looked into so far, like the milk fat globule, we've heard a lot about the fat content, the fatty acids. It is heritable and can be predicted on the basis of the infrared records. So we could really do selection for that. The next steps will allow us to develop prediction equations for other milk components, develop genetic and genomic evaluations for the predicted traits, and also it should allow us to relate the milk infrared data to recorded health events, including mastitis and hoof health. As part of our project, we have a great number of collaborators and students. This is in addition to the lead researchers, and we are also training many graduate students, and it has a very positive impact on the industry. We have people who are trained and who can be our next generation of researchers. So, in summary, I've shown you that genetic improvement and genetic progress plays an important role in the productivity of dairy cows in Canada. However, we can still, there's still room for improvement. We can increase the accuracy of genomic evaluation, introduce other traits such as hoof health and the nutritional value of milk. Other traits we're also looking into, for instance, the feed efficiency or the emission of methane, for which we could also do things at the genetic level. These projects are not strictly genetic. There's, for instance, if we look at the hoof health, we will also give producers and hoof trimmers data so that they can improve their management in the Canadian herds. These are the various organizations that have funded us and helped us out in this project. Thank you for your attention.
Our next guest is Doris Pellerin from Université Laval. Doris est titulaire d'une maîtrise en économie.
Has a master's in rural economy and a PhD in zootechnology, and she is a specialist in dairy farm production at Laval University. Her research projects are about development of sustainable agricultural production methods. Thank you. Hello, everyone. And my mandate is to try to convince you that, and to show you within 12 minutes, that there is a link between practices to ensure cow comfort and the cow's longevity, and at the end of the day, the sustainability of the farm. So the easiest part for me is the link between cow longevity and the profitability of the farm. So what you see here on screen are the results of a calculation that we've carried out, and we're using data from about 800 farms over 3 years, and we've looked at what point in their lactation does the cow become more profitable. So we know, we're looking at from which lactation does the cow actually become profitable for dairy farmers, and we see after the first lactation she's reimbursed part of her cost, but there's still a deficit of about $1,400, and it's only after the second lactation that you reach a neutral point. And I know that for you producers, making money is not necessarily the only thing that you're interested in, but still you might be fairly interested in knowing that if you want to be profitable, you need to have at least 3 lactations or more from your cow. But if you look at the reality, the Canadian Dairy Network data shows that only 40% of Canadian, 50% of Canadian cows survive their 3rd calving. So half of them only have 2 lactations, whereas life expectancy is about 6 lactations. So we asked ourselves, can comfort and welfare help in improving cow longevity and therefore improving profitability? And to answer this question, we've brought together a lot of collaborators in this project, and they are experts in all sorts of fields, those who know comfort, those who know health, those who know nutrition, and also those like me who know a little bit more about the technical aspects of management. And I need to mention that this whole initiative, the first people who chaired the network were Anne-Marie Depassier and Ron Terry, who are from the University of BC. So to do this, you have to have the thinkers, but you also have to have the people who carry out the work. So there are about 20 students, and most of them are women, and they've all worked to allow us to reach the results that I'm going to present today. So what are the research objectives of the network? With Cluster 1, we had been to 240 farms. We had looked at developing the parameters for comfort and tools to evaluate comfort, and that was the starting point for the welfare focus in ProAction. And we also felt, well, we have 4 goals. The first goal is to go back to these farms that were part of Cluster 1 and to try to see, for those producers who adopted strategies after our evaluation, some of them listened to us when they did, are they getting better results in terms of comfort? So that is led by Elsa Vasseur, who is now at McGill University for stalls. And the second goal is to try to see whether there are any other strategies that would enhance comfort or our knowledge of comfort. So any strategies that we might have, and that's with Derek Hawley from Guelph University. So we're looking at the focus farm group. Would this strategy allow us to improve comfort if people are more concerned, and we have these and we look at improving comfort. Now my domain is objective 3, and that's what you'll hear most about today, and it's about the economic impact of following the code of practice or improving comfort. And finally, we developed a simplified tool that was that can be used, and it was developed at PEI University, and these are people trying to work on simplifying the advisory tool in order to simplify evaluation of cow comfort. Now let's have a look at some very preliminary results and not so preliminary. I've put some in there that date back to the Cluster 1. Let's look at the results. Let's talk about freestall farms, and then we will have stalled farming. So what do you think? You need your little tools here. Here's the question. What is the average percentage of cows that were classified as visibly lame on the 140 farms visited during Cluster 1 that are freestall farms? Is it 0%? None of them were lame. Don't bother with it. 11% or 21%? Your answers, please. Oh, you're already answering. So the results are, oops, here we see 38% believe that 11% are visibly lame, and 21% feel, and two-thirds, 63% think that 21% are visibly lame in freestall farms. And if we look at actual results, 21%. So most of you were quite right. But what we have to note is that there was a great deal of variability from one herd to the next. There are some farms that get to 0 lameness, which is exceptional, and others have a rate of up to 69% lameness. So when you look at this overall, is this serious, having this level of lameness? Is there any way of reducing lameness? When we had our first visit, we developed a tool to evaluate how lameness is managed in freestall farms. Is there a link between lameness and the cow's milk production? And what you see on screen now is the milk production, and that's an average for the herd versus milk that's corrected for fat content, and the goals and criteria for managing lameness that had been created. Here you have a beautiful straight line. This morning we were told to give you a simple message. I think that this is a fairly simple message. It's clear cut. What we did is we had a regression between production, dairy production of the herd, and meeting lameness management criteria. And what you see here is that there's a very linear trend between the two if you look at genetics, if you take into account genetics, and that this is a significant trend. Now, what you have to take into account is that there are 2,000 kgs per cow on average. That's the difference between those who have a lameness management strategies and those who don't. Now, what's a lameness management strategy as part of this evaluation tool that we created? It takes 4 different criteria into account. First of all, less than 10% of the cows are obviously lame. Routine observation of cows for lameness. So we've set up a process to observe this routinely, also having proper treatment procedures for lame cows, and finally keeping complete records of lameness. Those people who did these 4 things, those who reached all 4 of these targets, they would get 2,000 more out of their cows than farms that don't reach any of these targets. So that's for freestall farms. So for all those who are west of Ontario, now you can leave the room because we're going to talk about tie stall farms. So for tie stall farms, a question for you. We're going to talk about neck injuries. You have an example here. An example here of what that looks like, a neck injury. So what should producers do to significantly reduce neck injuries at a low cost? So low cost, reducing neck injuries. What should the producer do? 1, move the tie rail forward to reach the standards, 35 centimeters in front of the wall. Lift the tie rails and respecting the standards, or stop evaluating injuries altogether. That way you're pretty sure you won't count any. So I'll let you vote. The results are on the right-hand screen. I'm pretty lucky nobody answered stop evaluating altogether. That's good. So we're hesitating now between moving the tie rail forward or lifting the tie rail. And I understand why you're hesitating, because before we carried out this study, we thought both were really equal. Either you would lift it or move it forward, or ideally you'd do both. But our results show that the main way of reducing neck injury is not raising the tie bar, and that's what we've seen in Quebec. The tie rail was lifted, and in Ontario it was the opposite that was done, and the repercussions on neck injuries were quite marked. And I'll show you the results. Here they are. What you see on screen, the light blue bars are farms don't meet the standard for positioning the tie rail, and in dark blue are farms that respect the tie rail. So let's start with neck injury, and you see a drastic decrease in neck injury between those who respect, those who don't respect the tie rail positioning and those who do, 29 percentage point difference. But that's not just for neck injury, because of course if you move the rail forward, there'll be less likely that cows will be pushing and so on. So there's also an impact on knee injury. You go from 48 to 28. Lameness is much reduced in tie stall farms when the cows don't need to push on the bar to get their feed. Now, the only inconvenience for those who have tie stalls farms that all tell us is that there can be an impact on the udder cleanliness, because if you move the tie rail forward, there's more of a tendency to defecate within the stall, and therefore you have to be much more careful about cleanliness. But comfort is often that there's always a compromise there between giving more comfort and still maintaining the cows in relative cleanliness. But if you look at the difference, the percentage of dirty cows is really very low, around 5%, whereas the percentage of cows with injuries is relatively much higher. So I think that the numbers speak for themselves. Now let's look at impacts, because we've talked about injury, but this increased comfort in tie stall farms, could that also mean better productivity from your cows? What you see here on screen are the results of the same type of evaluation. We had a look at the stall management and the impacts on productivity. So in tie stall farms, we had 3 criteria, and here you see the 4 bars. So for those who didn't meet any of the criteria, they had an average of about 8,400 kgs per cow, whereas those who respected all 3 criteria, they had an average of 9,200 kgs on average. So there's 800 kgs difference on average between those who correctly manage the stalls in a tie stall farm and those who do not. Now, what are the criteria, the targets that have to be met? We have having dry bedding in the stalls, clean stalls, but what's also important is how deep the bedding is for the animals. So one last point about longevity. With all of these efforts, we've seen that this can have an impact on cow productivity, but can it also have an impact on cow longevity within the herd? So we have some studies here in tie stall farms, and what we were interested in finding was what are the risk factors that cows in first and second lactation will push them to leave the herd. If they leave in the second lactation, it's too bad that they're leaving the herd, but at least they've paid for themselves. So, what are the risks? And here we see a lot of risk factors that are related to comfort. The first, the high manger curve. The higher the curve in front of the cows, the less likely they can get over them easily, and that will have an impact on longevity. Once you go 1 centimeter over the standard, which is 20 centimeters, you have a 2.4% increase of being culled. And then narrow stalls, every time you reduce the width of the stall by 10 centimeters below the norm, that will increase the risk of a culled cow by 15%. And then down to the very last line, when there were few incidents of lying bouts, when the cow can't get around in the stall, lie down and get up, that also increases the frequency of culled cows. So what do you need to remember from everything I've said over the past 12 or 13 minutes? There are some good and some less good news when we went on farm. So let's start with the bad news. Comfort could be improved on many dairy farms, and I think that that's what ProAction is looking to achieve. There's a level of lameness that is too high on certain farms. We've seen injuries as well, injury prevalence at a level of 40–50% in certain cases. That's fairly high, but also good news. And the good news is that the advisory tools that we have created are available. They are being improved over the course of time by the PEI team. We're also working on efficient solutions. We know a few solutions. I've told you about a few of them for lameness. And these solutions will not only improve the cow's comfort, but they also will be profitable, because we've seen that there's a link between milk production, and now that's the ground we still need to cover, but there's probably a link with productivity as well. So if you want to learn more, there are several articles that have been published as part of Cluster 1, a few of them as part of Cluster 2, and you can consult all of these various publications. Thank you very much to the DFC and the other organizations that have helped to fund our research. Thank you.
Our next speaker is Dr. Ronaldo Seri from the University of British Columbia. He is from Sao Paulo, Brazil, where he received his DVM degree from the College of Veterinary Medicine at Sao Paulo State University. Currently holds the position as an assistant professor in animal reproduction at UBC, University of British Columbia. Dr. Seri's research focuses on development of strategies to overcome the subfertility in dairy cows, such as the use of automated methods for detection of estrus, ovulation time, and health disorders. Moreover, applied and basic function of reproductive tissues related to inflammation and health are key aspects of his research.
Thank you, Shelley. And there we go. So this is. Sorry. So our project here for the dairy farms of Canada was based on sustainable gains in reproduction. Maybe not of you are all that familiar with the repro in dairy cows, but historically we have depended quite a bit on manipulation of the estrus cycle in order to breed animals. So most of you are familiar with synchronization protocols, fertility programs, which means you have to give exogenous hormones, to animals to make them, to become pregnant. This was not a, it can seem like a bad thing, when you say at the beginning, but it has been a very, very good tool for many, many years as how we do our reproductive programs in dairy cows. One of the questions way back when we submit our proposals to dairy farmers of Canada was, so what's next? What does it mean to be, or what does it mean to have a sustainable dairy reproduction program? This question is not as probably direct or easy as you would go for example, environmental effects or even welfare. because, reproduction was, and I'm going to show a few slides after that, reproduction has been going up in Canadian, North American dairy farms for the past 10, 15 years especially. And I'm going to show a little slide on this scenario and what should be our approach, for the future. The problem here becomes we have found a solution for infertility for some parts. It's not perfect, but time-at AI, what we call the synchronization programs, they have been used very successfully, and they've been doing quite well, in Canadian dairy farms, North American farms. And why I'm going to talk about estrus, because this has been the basis, and that should look like for you as a basic thing. But for the past, especially on the research side, we have forgotten a little bit what is or how to study a cow in estrus, in this natural state that which a cow needs to be before we actually breed the animal. And the research objectives for this project for dairy farmers, for their research cluster, involved the improvement of the knowledge of estrus behavior for this modern dairy cow. And when I say the modern dairy cow, is that a lot of the information that we had was from a cow that was producing a lot less milk, a lot smaller, in a different environment. Identify physiological and environmental factors that affected this expression of estrus. Also, management have changed quite a bit. We have become quite a bit better in terms of taking care in many aspects, not all the aspects, but in many aspects we're getting better. And the other two, implementing reproductive programs and technologies that could be used, to optimize herd reproductive, performance, and also this past one, which has a lot to do with these new technologies that we have now on how to measure things. Part of the information that I'm going to show today comes from these automated activity monitors. These activity monitors pretty much work like your Fitbit that you have, and measuring steps, sleepiness, and so on. And we have that for cows. So it measures lying behavior, standing behavior. Now we have some of these monitors, rumination. But for us, right now, activity. Activity basically saying, is she more active? Is she walking more? Is she moving more? And we'll see that, at the end, right now we do have probably the capability of actually not saying, oh, she has a strong estrus. No, we can say percentage-wise, how much is increased. And we see in actually how better it is to associate with fertility traits. The first one I'm going to focus just on, we have a lot of information, quite a few studies done right now and several underway. And before I bother, Shelley with my, can you remove this slide? Can you put more slide? Because I was trying probably to show a little bit too much. So I'm going to show a few of the results, and then we'll talk from there. This was a questionnaire that was led by our group, but especially from the group from Ontario, from Stephen LeBlanc in Guelph, and we submitted several questionnaires about what it is today, how is that Canadian dairy farms are breeding our animals, and we see here that we have quite a bit. We had like over 800 farms that responded to this questionnaire, and we see that visual heat detection still is numerically speaking, the highest. This is very biased because, obviously the majority of the farms that responded were, and we have the largest numbers in Quebec, but these numbers show that especially in tie stall farms, visual heat detection is still prevalent, which makes sense. The cow doesn't walk much, okay? So she's standing and lying basically. But as you move to larger dairies and to Western, especially the Western dairies, you start to having more of the time-at-AI and activity systems and also combined practices. Okay, so we're having a lot more of these activity monitors, actually an explosion of the use of these activity monitors in the past 5-10 years. What we also did have, it was the overall reproduction data from these dairies. If you compare these data, so the first one, pregnancy rate, the second one, the black bars, are insemination rate, which basically means how many or the proportion of the animals that were eligible that actually were found in estrus or were submitted to insemination. And the conception risk is basically for each of the animal that was bred, how many became, what is the proportion that became pregnant. So pregnancy rate is basically the most important value that you have, you know, for practical purposes for the dairyman. That's the number you're looking for. And this number of 17.5, this number seems low. It was even lower about 10 years ago. So we are increasing quite a bit this pregnancy rate, but we increase that by increasing the number of animals submitted to AI. And a lot of these gains have happened because Time at AI programs actually increased the overall number of cows that actually are bred. Activity monitors now are starting to pick up and probably it's getting better and better. Overall, these reproduction parameters in Canada have improved, and actually right now more technologies are available. Estrus behaviors, I didn't show much of the data. The next few slides we'll have some that will return to that. It is very, very variable. And part of the associations of these estrus behavior with physiological parameters are not very in line with what we previously believed. And that will open a few opportunities for us as well. And variation is also large within the same animal, which basically means the animal that shows a strong heat once do not necessarily always show a strong heat. And that will have implications later on, and hopefully we can go to that part, you know, in future studies about genetic selection. Some environmental, some physiological factors that affect this estrus expression. So this is in the bottom row, you have color, leg 1, leg 2. These are different types of activity monitors. And that was one of the keys also in our project, was to test different systems. Because we need to have, you know, at some point, if we're starting collecting large quantities, large amounts of data, we need to make sure that we can collect from several types of machines. So a few of those things are pretty, if you look at that, they are more or less what it was expected. So body condition score, if you have animals that are equal or below 2.5 in terms of body condition, which is a very emaciated animal, their duration of estrus and their intensity of estrus tend to be lower. Okay? Parity, the same. To the most part, younger animals, these first lactating animals, they tend to have stronger estrus than multiparous cows. If you look at that, and if you look also to the stage of lactation, so cows not in the very, very early, but you know, cows in early to mid lactation and late lactation, they have a little stronger estrus. With all of that, you would be a little bit confused as what would be the actual effect of milk production, for example, in this estrus behaviors. Because the belief was that always milk production will always be bad for reproduction. That was always the belief. And that would be always bad as well for estrus behavior. How is that important for this research cluster? Is that if we're starting to have too much of a tendency for higher milk production and lower expression of estrus, that would start to become a problem. People would go out and say, yes, so these cows are not showing heat properly, and that, you know, is not sustainable enough. What we basically see in terms of milk production and peak activity is that there's a very small correlation. If you stratify this data, yes, some of this very low production, 20, 25, 30, they might have a little bit more estrus intensity than the other ones. But overall, the difference is very small. Basically, you can have lots of animals here with very, very high milk production and still having this, peak of activity pretty high. So the idea here was that afterwards we correlated all of these things with fertility. And we had, I think some of the results were nice for not only for immediate use, but also for long-term use, maybe genetic selection. This is another one. I showed this one the other day. I believe lots of you don't care about the follicle diameter, but the idea here is that from a physiological point of view, in a reprophysiology, there's always these things. You have a larger follicle, you produce more estradiol. More estradiol will trigger this change in behavior that you become sexually receptive. That's how it worked for the cow. And we said, okay, so if the follicle diameter is higher, she's going to have a little bit more estradiol, she's going to show a better heat. The behavior change will happen, and it doesn't. So there's something else in the cow that is independent of what's going on in the ovary that actually triggers this change in behavior, this very, very interesting change in behavior. And again, one type of activity monitor, the second type, we have the same trend. And these two types, they actually measure activity in very different ways. One is a neck-mounted collar, the other one is a more like a pedometer. So that have raised quite a bit of following up questions and follow-up studies for us to understand how that really works. So body condition score and parity, as more or less expected, will increase intensity and duration of estrus. Normally those things are also correlated with fertility, meaning cows with better body condition score and cows with pairs, they normally have better fertility than the other cows with low body condition score and high or older cows. And surprisingly here, milk production did not affect, neither of our data affected the intensity and duration of estrus. These types of information will be eventually, for follow-up studies, quite important for us to determine right phenotypes in case we try to start a program, for example, for genetic selection for animals that not only have high milk production, but they have high potential for expression of estrus and so on. So implement reproductive programs and technologies that optimize herd reproductive performance. Those that are not that familiar with, time at AI and activity. So this time at AI here, what we see, this is really a figure that represents many of our studies. This is one, but we have 3 others, and some of the studies also done by some of the other colleagues, not necessarily related to this cluster. But we don't have much of a difference when you start to breed more cows based on activity compared to just time at AI. That's not to say that today we have programs that only rely on activity monitors or only rely on estrus, because there isn't. There's no study done that. And that reflects a lot, the reliance that the industry have had, in the past few years on time at AI programs. If you compare, so other studies, 30, 31, you always have, if you see only time at AI, you may start to think, this might have, a tendency to have greater, fertility, but that's not always the case. We won't have time to discuss that, but that's, if you look at, long-term effects, there is no difference. And this exploring these different phenotypes, I'll go quickly on this, but this is a very interesting result. If you start looking at, stratifying based on data that is collected from these activity monitors, you will see that, first of all, this is the first time we've been able to do that. There's no studies before trying to measure behavior, sexual behavior in dairy cows to this type of, there was some other studies, but not looking at the fertility the way we do. The only thing we see, when you see this one measured by the collar, quite a big difference in terms of pregnancy per AI. If you look at those measured by the leg, these are the same data set. And still something like 12 to 14% increase. This is a different data set from a different farm, and all of these studies were, with over 1,500 events, from Astra. So they were really large studies involving a really large number of animals. And again, we still have the same. We recently done another study with embryo transfer, and that holds true to, cows that are transferred to recipients that show high estrus at the beginning of the cycle. They have a very, very large increase in fertility. And this short-term application, basically combination of, for now, for practical purposes for the farm, combination of time at AI and some sort of estrus detection is still the best. And I think how we move on is basically what is the proportion that we would like to have. And also more can be taken from these activity monitors. This is a very underutilized type of information that we don't use it as much as, and those are, remember, those are 24/7 type of monitors that we have with the cows. Next steps, refining, improving this knowledge, and perhaps, we might have a window for this genetic selection, although we probably should be improving a little bit more on the phenotype. I don't know if you have this question here, but basically the question that we have is how can we improve repro programs? And this is something that, comes, I always have to answer these types of questions, all the way from friends to people in other industries and so on, that how we're doing, how we're moving forward. Reproduction right now is some of this, is one area that, for example, we have been able to solve at least partially this subfertility problem through these programs. But how do we want to move forward is something that is going to be very, I think, somewhat of a challenge, but at the same time, somewhat to think about. And, there we go. This is the same question, you should use the same, and probably it could be, I think, is a reflection of what it could be the challenge from now on. Parts of these reproductive programs, for example, use any available method, and that's how we've been doing so far. Whatever works, probably that's what we're going to use. Part of the problem, and I'm not, demonizing or anything for time, because I have used my whole career, some of these protocols. It is how do we want to go from now on. So this will show here that at least in this room, the majority don't. It's okay. We can use whatever, and that should be fine. I have somewhat of a different opinion, probably more or less here, as long as we have the right technologies, but that's true. And I'd like to just acknowledge, my collaborators. I don't have the time here to tell all their names, but, Anne-Marie de Passier and Jeff Russian have been a big help for me at UBC. Stephen LeBlanc from Ontario Veterinary also have done a lot of work with us. And obviously all my students that without them would be nothing. And thank you very much for the research cluster. I would like also to thank, help that I have always had, from the Western Endowment Fund in BC, and also from the DIREC, which is a program from the BC Dairy Association. So thank you very much.